Hey, what's up? This is Mr. Love again. This is still homework number 210. This is problem number 2. Um, let's see. We're still working on power and work. This problem is reading what is the potential energy as a result of gravity of an automobile on a mechanic's lift. The car has a mass of 2,000 kilograms and it's lifted 3 meters. If the car is lowered by 1 meter, what is the new potential energy as a result of gravity? As always, I like the pictures. So what we can do is draw a very simple car up on a mechanic's lift. Okay, and there's some information that's given here. It says that the mass of the car is 2,000 kilograms. It says that the distance that it's lifted is 3 meters, so that D is equal to 3 meters. That's the first part of the problem. The second part of the problem asks what happens if it's lowered. So this one, the solution is a bit simpler. We have an equation that refers directly to this. Potential energy of gravity is equal to the mass times gravity times height, where G, gravity, is 10 newtons per kilogram. Okay, that's a constant. Again, that's always given. So some simple substitution makes it look like this: 2,000 kilograms times 10 newton per kilograms times a height of 3 meters. So if you go ahead and do that math, you have 2,000 times 10 times 3, and that's equal to 60,000. And looking at the units, this kilogram cancels right there, so you're left with newtons there and meters there. So it's 60,000 newton meters, or 60,000 joules. Okay. The question goes on to read what happens if the car is lowered by 1 meter. What is the new potential energy of gravity? So simply all that does is change this distance here to 2 meters. So you can go ahead and redo the equation. Everything is the same with the exception of the height. 2,000 kilograms times 10 newtons per kilogram times 2 meters this time. So if you go ahead and do that math, it's 2,000 times 10 times 2, and that works out to be 40,000. Again, the kilograms cancels, so you can get 40,000 newton meters or 40,000 joules. Okay, and that's the solution to problem number 2.